All right, in this example, this comes from your textbook, number 104. So I'm going to read it. You should have already read it, so you kind of understand what we're doing here. So number 104 says we're going to model radioactive decay. So suppose that a 0.05 gram sample of a radioactive substance decays to 0.04 grams in 20 days. How long will it take for the sample to decay to 0.025 grams? So the first thing that we want to do is we want to make ourselves a little chart with the information. So we have amount, and that's in grams, and we have time, and I think the time is in days. Okay, so amount is in grams and time is in days. So we know at day 0 that we have 0.05 grams. And then we know that 20 days later it decayed, and now we have 0.04 grams left. And so let's use this information first to find R. So it's continuous decay, so we're going to use PERT. Okay, so A is the amount. At the end of 20 days we have 0.04. P is what we start with, so we start with 0.05 E to the R. We don't know R, but we know time is 20. So now we're going to solve for R. So we're going to divide both sides by 0.05, and I've got 0.04 divided by 0.05 equals E to the R times 20. Now I want to natural log both sides. I like the natural log. So when I natural log that, I've got the natural log of 0.04 over 0.05. Remember, we're going to hold all our calculations to the end. We have 20 times R times the natural log of E. The natural log of E is 1, so that disappears. And then we're going to divide both sides by 20. And then when you key this in your calculator, and I've done that right here for you, so I've typed that in. So I've got the natural log of 0.04 divided by 0.05, close my parentheses, divide by 20, and here's my R. Now, I'm going to keep all those decimals right there in the calculator until step number 2. But on our paper, let's go ahead and write to 4 digits what our R is. So there's our R, our rate of decay, negative 0.0112. Part 2 of the problem says when am I going to have 0.025 left? So I'm just going to set up the equation. So 0.025 is the amount, and P is my starting amount, which is 0.05. E to the R, there's my R, 0.0112 negative. And we're solving for T, so T is my variable. Divide by 0.05. So I've got 0.025 divided by 0.05 on the left, and I've got E to the negative 0.0112 T. Now we're going to take the natural log of both sides, and when I do that, I've got the natural log of 0.025 divided by 0.05, and when I do that, that releases the exponent, so it comes down in the front, 0.0112 T times the ln of E. You recall the ln of E is 1, so that disappears. And now I'm going to divide both sides by negative 0.0112. And I'm going to show this over here, divided by negative 0.0112. And this is my T, and follow my arrow over here. So T is going to be the natural log of 0.025 divided by 0.05, all divided by R, the negative 0.0112. We want the absolute most accurate answer, so what we're going to do is we're going to use our calculator this way. So there's that R right there in all its decimals. So I'm going to key in the next part. I've got the natural log 0.025 divided by 0.05. Don't forget to close your parenthesis, divide by, and now we're going to use that second answer. Brings in all those decimals. And you get 62.125, and for this example, let's just round that off to 2 places, and in other examples it might be really important, however many decimals that you have. But right now we're just going to round that off to 2 places. So in 62.13 days, this radioactive material will have decayed to 0.025.